Hey everyone, my name is Franzi, and this time we'll be creating a little game that is on the topic of lack of clean water. And the basic idea is that you're collecting these polluted particles before they reach the end of the stream, and at the same time you have to avoid getting hit by these logs. Uh, Also, besides being damaged by the hit from the log, if you let too many particles pass through, you will obviously reduce the water pollution to unsafe and later to toxic. And with each particle at that point that passes through, you will also get damage from the escaped particles, not only from the logs that you're hitting. We'll be creating this displace map that creates this gorgeous water effect, and basically all of the functionality with the heat tests, so the collisions and the movement of the ship, and also the slight panning of the background. So here we go. Now it's toxic, and now we're actually gonna die. Yeah, here we go. Anyway, we'll be starting off with creating the displacement map. And what we'll actually be using here is a PerlinNoise, which is a generator of this random black and white pattern that actually allows us to displace this background, this water, in such a random way that it actually looks so fluid and like water. So let's get going, and we'll be needing a bitmap data. And this one will be to actually create that PerlinNoise over. So we'll actually make it the width and the height of our mask that is masking our image in the background. So this is the image over here, and if we uncheck the mask, you see that it's just a static image with it's actually created inside of view with displacement over the water material. So we already have some kind of a displacement, but it's not animated. And we'll do that animation with creating that displacement map. And this is the mask that is masking the part of the image that actually needs to be displaced, right? So having this be any bigger than it has to be, we would actually slow it down, because this PerlinNoise and displacement map is quite a intensive process, so we want to keep it as small as possible. And even this might be too big for some people, but anyway, we'll go and create it as it is. So we have scape mask and scape mask height, so width and height, and we'll mask the landscape displacement. So this is the actual movie clip that we'll be displacing. We'll mask that with the scape mask, and we'll be displacing, so creating that displacement map over the landscape displacement movie clip, and masking it with this guy. So if let's check it out. If we run it, we already see everything in place, and all of the objects, by the way, are already placed as they should be. We'll just go in and add all of the code that we need to make this process a little bit smoother. So let's create the displacement now. So we'll need a bunch of variables that will actually pass later into the PerlinNoise and the displacement map filter. So first of all, we'll create the base X and the base Y, and num octaves random seed, and we can make this anything. Let's say math random. In this case, doesn't really matter that much. Stitch, and I'll explain these in a second. Fractal noise will also be false. Channel options number equals bitmap data channel, which is the channel that we want to pull out of the PerlinNoise, and that'll be blue in our case. Then we have the grayscale option, again false, and offsets, we'll make it an array, equals new array, and new point. Here we go. We also need the displacement map, so dmap will define the scale here with the variable, so number, let's say 5, and to create this elongated effect along the y-axis, so it's kind of flowing down, right? We'll make this one 40. So y is much more stretched than the x-axis. Now we use the component x u integer. Let's just copy and paste this bitmap data channel, and var component y u integer. Here we go. One more, and that's displacement map mode, and we'll use that as displacement map filter mode clamp. We have a couple more, and you can check them in the documentation. Every one of those does a slightly different thing, but we'll use clamp and it works nice in most cases. And now to define the displacement map, we'll use dmap equals new displacement map filter bmp data, so bitmap data, new point, component x, component y, x, let's go to the next line, x, scale, y scale, and displacement map filter mode. Here we go. Let's also do the loop, and then I'll explain the stuff that's up there. So add event listener. We have event enter frame on frame, let's call it, and false 0 true. Function on frame evt event void open and close, and we'll be moving the offset over here, so we'll be constantly animating our PerlinNoise, so we'll create that animated water effect. Here we go, and we'll be creating the bitmap data PerlinNoise. So dot PerlinNoise noise. Here we go, and now pass in the base x, base y, num octaves, random seed, stitch, fractal noise. Here we go, fractal noise, channel options, grayscale, and offsets. Here we go. One more thing to do, landscape displacement filters equals the map. Let's try it out, and immediately we get the same kind of effect we saw earlier. Anyway, to go up here and check out what this is. If we change the base X and Y, we actually change, let's make a drastic change. We change the size of our ripples. So we're actually making it much larger, and in our case, you know, it makes pretty much no sense to have them this huge. So base X and Y works nice in our example as 5. Okay, creates this nice and detailed effect. Num octaves actually kind of provides the level of detail. The higher you go here, the less, the slower the whole thing will go. And if you can pull it off with 1, and I think it's in our case possibly even nicer with 1, we want to keep it that way. Okay, so now if we go to random seed, this is where in the whole PerlinNoise generation it'll take out a sample. And in our case, it's not really that important because we don't need any kind of randomness. We just want to create this kind of organic pattern, and it doesn't really matter whether it's changing the place where it's kind of sampling from or it's staying constant. Stitch tries to create a seamless stitch in the bitmap if you're using a PerlinNoise over it. And in our case, it doesn't do much if we set it to true. Fractal noise is, if you don't want turbulence and you want fractal, you select true over here. Turbulence has a bit more of a defined edges on its displacement. So in our case, it actually works better as turbulence. Channel options, you can select blue, green, red over here. And it allows you to create all sorts of displacements. But since we only need 1 channel, right, because it's only going up and down, we select blue over here. Grayscale, it forces it to be grayscale. Again, we don't need it. Offsets is an array just prepared so we can actually pass it in here as creating those offsets for animation, for animating our PerlinNoise over time. And going down to DisplacementMap, this is just the stuff that needs to be defined in order to create a DisplacementMap. And the only thing that needs explaining over here is the scale, or doesn't really need that much explaining. It's just the only thing that if you change, you actually get a much different effect on our PerlinNoise, right? So depending on what you like, basically you can change these settings, but keep in mind that creating a huge or even a full screen PerlinNoise effect many times doesn't really work that well. So you might wanna try and optimize it in some way, and creating a smaller object over which you're actually creating a displacement and masking it if you're creating a river, as we are in our case, is actually a good way of doing that. So let's just slightly adjust it. Anyway, it's a simple mask, but it does okay for our purposes. Okay, so we've created our displacement map, and now we'll actually go on and create a foam particles class, which will create that foam. If we check out the final version, you'll see that our boat leaves the foam kind of behind as a wake in the water that it's traveling over. So we'll try and create that that effect by creating a class that we'll call foam particles.